This is the Chem 1 lesson over 3 different types of chemical reactions, synthesis, decomposition, and combustion. So we're going to talk about how to identify types of chemical reactions today. There's going to be 5 different types, and then how to be able to predict what those products are going to be. Don't forget your diatomics. Those are 7 elements that when they're by themselves do pair up. So there's 7 of them. We've gone over them numerous times. Be sure you have a handle on those. So we're going to cover 5 different types of chemical reactions total in the course. Today we're going to talk about synthesis, decomposition, and combustion, and then at a later lesson we'll cover single replacement and double replacement. So synthesis is just like this picture shows. You have 2 things coming together to form one thing. So typically it's going to be 2 elements coming together to form a compound. So you're either typically going to have 2 elements coming together to form a compound. So if you had element A and element B, it would make a compound made of A and B. So if those 2 elements are sodium and chlorine, it's going to come together to form sodium chloride. Let's see, we got to balance this guy, follow the law of conservation of mass by putting a 2 in the front there. So 2 elements, sodium, explosive metal, chlorine, toxic gas, put them together in a chemical reaction and you get delicious table salts. Remember, those properties change when those elements come together. When an element has more than one oxidation number, sometimes you are stuck with trying to figure out what that oxidation number is. You will be given the you won't necessarily will be given the symbol, so you won't necessarily know the charge. So you are going to have to be able to look it up. Most of you guys have noticed this on the back of the periodic tables under your reference sheet. You get this handy little box with kind of the most common transition metals and their common charges, and then we've circled the most common charges. So they can be, for example, arsenic can be 3 or 5. More often it's 5. So if you have to make a guess, if you have to choose, you need to choose 5. There is a special case, kind of a weird exception to this that you do need to know, so you probably want to highlight that, is when you have a metal oxide combined with water. So a metal oxide is any metal with oxygen. It's going to come together in a synthesis reaction to form metal hydroxide. Now, it's not necessarily super logical because it is not 2 elements coming together, but it's 2 compounds. So here's a metal oxide, sodium oxide, and water. It comes together to form sodium hydroxide. We'll have an example of that in a minute. So we've got some examples. We can recognize these as synthesis reactions because the reactants are 2 elements, generally speaking, so they're going to come together to form a compound. So if we have iron and chlorine, they're going to come together to form a compound. We have to come up with what kind of compound would be formed with Fe and Cl. Don't forget, chlorine's a diatomic, so it should be Cl2. So I know it's going to have to be ionic compound between iron and chlorine, which means we're going to have to crisscross the charges. But there's no way for us to tell the charge on iron because on the reaction side it's just solid neutral iron. So you're going to have to use your valences of common transition metals on the back of that periodic table. If you look up iron, iron is +2 or +3. +3 is circled. So when we have to choose, we're going to say that it's iron +3. So it's going to be FeCl3. So we need to come up and finish our word equation. It's going to be iron 3 chloride. So now we need to balance our chemical equation. The chlorines aren't balanced. I got a 2 and a 3, so the lowest common multiple between a 2 and a 3 is 6, so I need to make them both 6. So I would put a 3 in front of my chlorine, and then I would put a 2 in front of my iron 3 chloride, which changed my iron, so I need to go ahead and put a 2 in front of Fe. Now the next one looks a little bit different because it's our special case. It's a metal oxide and water, so I've got magnesium oxide, Mg, CO, magnesium's +2, oxygen's -2, so they're going to be in a 1-to-1 ratio, plus water, arrow. So now these 2 come together, it's our weird case, it's going to form a metal hydroxide. So in this case, our metal is going to be magnesium. So magnesium and hydroxide. Magnesium's +2, hydroxide's -1, so we're going to have to crisscross our charges. So we're going to get, let's fix that, MgOH2. So up in our word equation, we can finish it out by saying magnesium hydroxide. Balance this guy out. Let's see, my magnesiums are balanced. So we need to balance our elements here. So this is not a situation where you can think about water as HOH since I have oxygen in two places on my reactant side, but I do have two O's and two H's. If we come over here, oh, I think it's already balanced because I've got two H's in water and then I have oxygen in two places, right? I've got oxygen over in MgO and H2O, so actually this guy's already balanced. Gotta love those. So we've got one more to look at. In this last one, I've got zinc and oxygen, so I've got zinc and oxygen. Oh, okay, getting all our diatomics in today. O2. So they're going to come together to form a compound, so it's going to be between zinc and oxygen. So zinc is +2, oxygen is -2, so it's just going to be ZnO to balance it out. Let's see, my oxygens aren't balanced, so we'd have to put a 2 in front of ZnO, which means we would then have to put a 2 in front of our zinc, and now it's balanced. Do not forget to go back and finish your word equation. Zinc oxide. So I've done a couple different ways. First, for me personally, I like to finish the equation with symbols and then go back and finish the word equation. It doesn't matter the order you do it, as long as in the end you have finished your word equation and you have a balanced chemical equation. Our next type of chemical reaction is decomposition, which is the exact opposite of synthesis. So synthesis was two things come together. Decomposition is one thing, like this lovely couple here, breaking apart into two separate things. So it really is the opposite of synthesis. So if we have a compound that's AB and we're going to break it apart, we're going to turn it into element A and element B. So we're going to turn it into element A and element B. So we're going to have two elements here. So if it were aluminum oxide, we're going to break it apart into the two elements. We would have aluminum and oxygen. Heads up, it's a diatomic. It's already halfway balanced for us. We need to finish it out. 4 aluminums and 3 O2s. So usually you have to put some form of energy into this to make things decompose or fall apart. Heat, light, electricity, mechanical shock. And there's a lot of special cases, especially when there's polyatomics involved. We're not really going to concern ourselves with those. There is one you need to know, which is the exact opposite of the synthesis weird case. This time it's the opposite. So we're going to take a metal hydroxide and break it apart into a metal oxide and water. So the synthesis and decomposition special cases are the same one, just opposite directions. And you'll see an example of that in a second. So water, if we've got to break water apart, we've got to think about what two elements we have here. Water is H2O, so if we're going to break that apart, it's going to break into hydrogen, which is a diatomic, and oxygen, which is a diatomic. So we need to balance it out. My oxygens aren't balanced, so we need to have a 2 in front of water. But that now messed up our hydrogen, so we need to have a 2 in front of our hydrogen. Now that guy's balanced out, let's go finish the words. So we're going to have hydrogen and oxygen. The next one, let's look. I've got lithium nitride. So maybe you want to go ahead and write out your symbols. So let's see, lithium. Here we go. And nitride, which is just nitrogen. Nitrogen is -3, so it's going to be Li3N. So now we're going to break it apart into the two elements. Those two elements are going to be lithium and nitrogen. So let's think about it. Is nitrogen a diatomic? Yeah, it is. So it's going to be N2. So let's see. Maybe you want to go finish the word equation next. So that's going to be lithium and nitrogen. And now we need to balance that chemical equation. So at first I'd put a 3 here and a 2. Uh-oh. So I have to change my lithiums, right? So now to balance my nitrogens, I had to put a 3 in front of Li3N, so it's actually going to end up being 6 lithiums. And last one is our special case, so you probably want to give that guy a star. Copper, it's a metal hydroxide. So copper 1 hydroxide is CuOH +1 - 1. arrow, when it breaks apart, it's going to break apart into a metal oxide and water. So in this case, my metal oxide is going to be with copper. So I'm going to have copper and oxygen. In this case, we do know the charge on copper. It's +1. So I'm going to have 2 of them to balance out with the oxygen. That's -2 plus water. And maybe we want to first balance it first. It doesn't matter the order. Coppers need to balance, so I put a 2 there. And, oh, I think it's balanced. 2 coppers, 2 oxygen, 2 hydrogens. Yep, it's balanced. So now let's go back and finish the word equation. Copper, 2 oxide, and water. And third type of chemical reaction we're talking about today is combustion. Combustion reactions are really easy to pick out. They're always going to start with something called a hydrocarbon and oxygen. We've talked about hydrocarbons before. Hydrocarbons are just that. They contain hydrogen and carbon in any combination. So in your example up here, it does say CXHY because it really is literally any combination of those two things. Then they have really wacky names. You guys have seen before, pentane, octane, things that you're not going to be responsible for naming, so you will be given those formulas, and in order for anything to burn, you have to have oxygen. And they're really easy to predict what the products are because if you combust a hydrocarbon, the 2 products are always going to be carbon dioxide and water. So if we've got C2H6 and oxygen, we're going to form carbon dioxide and water. What can be tricky about these guys is balancing them. So this is already halfway balanced. I've got 4 carbons, so I'm going to need 4 CO2s to balance that guy out. I have 12 hydrogens on my reactant side, so I'm going to need a 6 in front of my water. And they're tricky because the oxygen's in 2 places, so I've got 14 oxygens on my reactant side. I've got, let's see, 8 oxygens and CO2, and I have 6. Oh, so that's also going to give me 14. So now we've got it balanced. Combustion, it's going to react with oxygen. It's going to produce a large amount of heat and light. Produces a lot of gas. Also, that carbon dioxide and water will end up being a gas because it's so hot. Commonly involves hydrocarbons. You can combust other things, but we're not going to cover that in here. The coefficients can be pretty large, so you want to be sure that you balance oxygen last. So, our examples, propane and oxygen. So you can see propane, that's not something that you're responsible for knowing the formula for. That's going to be given to you. So we've got C3H8 and oxygen, which is O2. So you can recognize this as a combustion because it's a hydrocarbon and oxygen. So I know my products are going to be carbon dioxide and water. So now the hard part is balancing it. So again, I suggest balancing oxygen last. So first I would choose to balance my carbons. I'd probably put a 3 in front of my carbon dioxide. My hydrogens, I'd have to put a 4 in front of water. Now stop and add up your oxygens. On the reactant side, I got 2. On the product side, let's say I have 6 plus 4. That gives me 10 oxygens. So I'm going to need to put a 5 in front of O2 to get that balanced out. Don't forget to finish your word equation by writing out carbon dioxide and water. And the last one, octane and oxygen. So I've got C8H18 plus oxygen. I know it's going to be CO2 and H2O. So we need to get our coefficients in there. So I'm going to have to put an 8 in front of CO2, and I'm going to have to put a 9 in front of hydrogen. So now let's pause and add up our oxygens. I've got 16 plus 9 is going to give me 25. Yes, math, 25. So how on earth can I get 25 out of O2 is to temporarily put a 12.5 there. Can't leave it as a decimal number, but we can put it there temporarily. It's not balanced, but in order to make everything a whole number, we're going to have to double everything. So we're going to end up with 2, a 25, a 16, and an 18 to balance our equation. Oh, I almost forgot. I got to finish our word equation, carbon dioxide and water. Okay, we've finished our first 3 types of chemical reactions. Synthesis, 2 elements coming together to form a compound. Decomposition, the exact opposite, taking one compound, breaking it apart. And combustion, where you have a hydrocarbon and oxygen, and it's always going to give you carbon dioxide and water.